Hello, everyone. Welcome back. Announcements. Number one, today I want to talk about your next assignment. Assignment number 5 is going to be due in a week, as usual. So you're going to have 1 week to work in a new assignment, as usual, programming. So you're going to submit your program, source code, it should work, run. I am going to ask you for the design, the class diagram, and a small document. So details on Canvas, I am going to explain the specification for the project, the goal of the project. That is my goal for this lecture. So assignment number 5 due next week. The plan is to have another assignment, so to make a total of 6. So next week, I am going to introduce the instructions for assignment 6, and it's going to be due our last week. Also, talking about the end of the semester, some people ask me about the final exam. It's something that we already mentioned before, at the same time that the midterm. Your final exam is going to be April the 21. My plan is to do the exam during the lecture time in our last session. So that is Wednesday, April the 21. The exam, the final, important things, comprehensive. So every topic is included from the lecture 2 until the end, and it's going to be the same format that your midterm, online, on Canvas, with the software that proctor and record you. So more or less the same experience that you already live with the midterm. Open questions, multiple choice questions. Good idea for you to start reviewing everything, review your quizzes, review your midterm. Any question, let us know, office hours, emails, whatever. Any question in your quizzes or your midterm could be there again. For your final, obviously you want to answer correctly again, or this time correctly, whatever. So final exam, April 21, due date for assignment 5, next week. And there are going to be another assignment that is going to be due a week after. So probably the same week that the exam is going to be your last one. It's going to be an easy one. You could finish in a couple of hours, 2 or 3 days if you want to split in days. So 6 assignments in total. Also, next week, we're going to have a quiz. With that, we're going to complete 6 quizzes. So for your grade, 6 quizzes, 6 assignments, and the 2 exams, the midterm and the final. And you can do the maths about what will be your final grade. So we're almost done. Assignment 5. The assignment 5 is all about software architecture. Software architecture. In particular, I want you to have practical experience with the architectural patterns. We reviewed 3 quickly, the diagrams and the source code. We talk a lot about the model view controller. One pattern that you should have proficiency, model view controller, split your application, separate in your application the graphical user interface for the user, the functionality, and the controllers, the connections of the events, the listeners, separated. So I am going to ask you, requirement number 1 for your assignment 5, apply the model view controller correctly. That is going to be one thing. Second, we review another patterns, in particular, the second one that we review, another equally important to the MVC, the Blackboard. This idea of a central place, shared memory space, in which you have your data and several processes are working with that data. Particularly with this pattern, we do an implementation, we show an example, including multi-threading. I show you this diagram with the Blackboard at the center. It uses a class for the data, but connected with different threads. I give you the example with the students and professor, several students, one professor, using the Blackboard, this space to put data, read data. We are going to put together this one and this one for a particular application that I am going to describe. I am not asking you to use the client server, the sockets, not yet. For this first assignment, assignment 5, these 2, let's see if we can use this one in the last one. For now, use 2 patterns, put them together. The challenge is to put them together correctly. And the challenge in terms of technology is your first application with multi-threading. Hopefully during the weekend, if you are not familiar with Runable or threads, you have the opportunity to review that. Again, any question, let us know. But I am assuming that you know multi-threading or you used sometime the previous week to study multi-threading. Several different resources available. So moving forward, your assignment, easy. Number one, I want to ask you to split your program in those three packages. I am going to represent these packages as boxes. They are not UML diagrams. I am not going to give you, not for the package, UML diagram, because I am going to be playing with some cartoons to explain my idea. So I draw here three boxes. My request for you, for the first time, I am asking you to create packages in Java. If you're not familiar with packages in Java, please send me an email, ask the TAs. But I am asking you for three packages. I am going to mention more for this slide, three packages. I am asking you to separate in different packages. What do you consider the view? What do you consider the model? What do you consider the controller? So step number one. Yeah, I am aware that there is one lecture, one video missing there. People is taking care of that. Hopefully it's going to be there tonight or something together with this one. So yeah, I am aware of that. Don't worry. So three packages, three folders, view, controller, model. It is not the best practice to use these names in real life projects. However, I am asking you to use these names for your homework. Why? To make the life of the TA, the grader, easier. So please use these names for your packages. I know in a real life application, these are not the names that you use. These are the names of the template. For your homework, I am asking you to use these names so the grader can identify easily what you are submitting. Good. So three folders with those names. Moving forward, in your folders, I am asking you for the functionality to use a Blackboard. For the functionality, I am going to explain the functionality, but my point is some of the functionality here, some of the model, if you remember, the functionality is there, is going to need a shared memory space. And we're going to model that shared memory space with a Blackboard. And as you remember, with the Blackboard, you have two different entities using the Blackboard. What we call it the student. Remember that the official name is knowledge source. That is the name that I am going to be using. They are not going to be specifically students, but knowledge source. And we have what we call it the professor in our examples. Remember, the official name is the control. So the professor, the students, the Blackboard. Official names in the template, the one that I put in the picture, the control, the knowledge source, and the Blackboard. So just for you to remember these ideas. So model view controller and Blackboard. Together, they are going to look like this. Let me be clear. Step number one, the Blackboard pattern is going to be inside of one of the elements in the model view controller, the model. Why? Because the Blackboard is all about handling data. And something that you told me in the previous week, the previous lecture is, well, handling the data is a responsibility of the model. Handling the data is not about the graphical user interface, it's not about the listeners, it's about the functionality. So what we're going to do is, for handling the data inside of the model, use a Blackboard, which basically means that inside of the model, this box, we're going to have the Blackboard, the students, the professor, the Blackboard, the control, and the sources of knowledge. Make clear? That is the connection between the two architectural patterns. One is going to be inside of the other. The big one, the one that is outside, model view controller, the view, the functionality, the listeners. For the functionality, we split again, and we split using the Blackboard pattern. We're going to split the model in three, the three that we already know. Okay, good. Nothing new here. Remember, I am asking you for three packages. The only things that are going to be packages are the gray boxes. So you're going to have a package view, a package controller, and a package model. These blue boxes inside of model, I put them there, used as a reference, but I am going to show you the classes. I am going to continue moving forward with this picture. So far, three packages, the gray boxes. Something is going to happen with model. I am going to explain. So next, 3 steps for your project. I am going to describe the generality. I am going to give you the ideas. I am going to give you a partial class diagram that I want you to complete. Also, I am going to give you some lines of code that could be useful for you. I am not going to do the assignment. You're going to do the assignment. But I think it's important, it's useful if I give you some hints for the design and for the programming. So that is what I am going to do in 3 steps. Step number 1. The first thing that I am going to ask you to do is your assignment is going to have a graphical user interface, a frame like this one. And I am sure that you know how to do a window like this. I want your application, your assignment to run and show me this window, an empty window. You have done this before. Nothing complex. Can you agree that when I ask you to do this, in terms of the design and the programming, what I am asking you to do is something like this. I am asking you to go to your folder view, the package view, and there I am asking you to create some classes. And I am sure that you can agree with me that you need JFrame. It's a class from a library. I am showing the class without methods, without attributes. I am asking you to use swing. I am asking you to use this class. Moreover, I am asking you to use inheritance. The connection of your class with JFrame is going to be inheritance. We have described why before. So one thing that the graders are going to do is to review that you apply inheritance. If you apply composition, aggregation, or something else, that is going to be one aspect in which you could lose points. The diagram is asking you for inheritance. Please use inheritance. Second, obviously, you are going to need a class, the one that is going to have your main method and the constructor. At this point, hopefully, you are aware that everything related with assembly, the graphical user interface, is going to happen in the constructor. At this point, you are aware what you need to do in the main. And those are 2 things that we're going to review. What is the correct number of lines that you should put in the main? What is the thing that you should put in the main, the constructor? So you know this, so far so good. Next, I am asking you to have your frame and only one element inside. That probably is not easy to notice, but the only thing that I am asking you to have here is the frame. And inside of the frame, all this space is one panel. One panel using the full frame. What I have here is one frame and inside one panel. The frame is the main, it's a JFrame. And I am asking you to have here inside one panel. That panel is a panel. I am asking you to apply inheritance from panel in another class. I am calling that class canvas. It's going to be a panel. It's going to have a paint component method. Later, I am going to ask you to make this guy an observer. That is the reason because the method update. But so far, I am asking you to create a panel. And because it's a panel, it's going to have a paint component. That's it. You have done this before. Hopefully with this diagram, you know exactly how many lines of code and what kind of code you need to put inside of these two files and the two libraries that you're going to use. These classes, main and canvas, should be in your folder view because they are graphical user interface. Done. The listeners. I am asking you to create a class a specific class for the listeners. In particular, I am asking you to implement mouse listener. That is the listener that we're going to use. And remember, the listeners are controllers, and they are going to be in a different folder. So I am asking you to create a class reporter, and that class is going to implement mouse listener in a different folder, in a different class, but every single time that the mouse does something with this panel, the report of that event should go to this class. In particular, and in order to make this more generic, every time that something happens with the mouse, not only in the panel, but in the full frame, in any place in this graphical user interface, any activity of the mouse in this picture should be reported to this class. And as you know, the mouse listener, those are the methods that you need to implement, all of them. So you can notice my connection here, association, because it's a use. I am asking you to implement exactly this diagram. No global variables. If you notice, for the main, I do not have any single diamond. And that means no global variables, no attributes. And we are going to grade that. This is mandatory. It's not just an advice or an example. I am asking you to be the developers of the blueprint that I am explaining to you. So far, if you notice the diagram, there are no global variables. There are no attributes in any of these classes, not yet. So this part, the view, the controller, mandatory, follow this design. Obviously, that includes use those names. Main, canvas, reporter. Those are going to be the names of your classes. And the methods that are mentioned here, those should be the methods that you need to include in those classes. Hopefully, so far, so good. Step number one, for the model view controller, I am asking you to separate view and controller, two different classes. The assignment that you did before, if you used the mouse listener before, probably you put the listener in the same class that the main. I am asking you, separate. Good? Next. Something that can be useful for you, I am just giving you ideas, depending on the experience that you have programming. Probably this code is going to make sense. And you can think about this like a quiz. Can you tell me this instruction, this instruction, this instruction, this instruction, and this instruction? Notice this. That is a hint. Where are you going to put these lines? These lines can help you to solve the problem. I am maybe giving you the solution for some of the things that I am asking you to do. If so, can you copy paste these lines? Where? In the class main? Yes. In which method? main the main the constructor, main the public static void main. My recommendation, hopefully you agree, main the constructor. So those instructions, my recommendation here inside of this method. If you are following me, if you know what I am talking about, when I recommend you to put these lines inside of this specific method, if you can explain why I am asking you to do that and how that is going to work, you are moving forward. You have been here the last 3 months. So step number 1, literally, I am asking you to do this class diagram. Yes, I am asking you to use these lines, put these lines in the place in which these lines should be. Moreover, can you tell me what is going to happen, what could happen if you copy paste this method, that lines inside of this method in this class? You're going to do these classes, you're going to do the connections that the diagram is showing you, and then I am asking you 1, 2, 3, 4 lines, copy, paste those 4 lines inside of the method, mouse click it. When that print is going to be sent to the screen, what is going to be printed? Do we agree on that? Can we agree that what I am giving to you is a program that is going to print on the screen in the console? If I click here, for instance, it's going to print something. And if I click here, it's going to print something. And the something is the X and Y coordinates of the dots that I am creating. So basically, I am giving you the source code for an application that print on the screen the coordinates of any click of the mouse. And something is going to happen with this. Okay. So, Professor, I do not know how to work with the mouse listener. I do not know how to work with listeners for the mouse. I am giving you the source code that you need. Maybe you need to review some tutorial or something extra if you have no experience. But at the end, this is the source code that you need to create a graphical user interface like the one that I am showing you, with a mouse listener, in particular, a mouse listener that gives you access to the coordinates X and Y on the screen in which the user is clicking. Good. What you have, if you follow the diagram and use the source code, is an application like this one. This is just your console, and the output is going to be something like that. X equal a number, Y equal a number. The format is because these things that I put here, the comma, the equal, the X, Y, those strings are because of the print. The important thing are these values. Those values come from the event. And those values are these values, the important numbers, 14, 52, etc. You know where the user is clicking. Good. And moreover, you are following model view controller. We have the view, we have the controller with mouse. Good. Next. Step 2. I split this in steps because my recommendation is you have 1 week to work. As usual, you can start working 1 day before and maybe ask for extra time or something. My advice, start working as soon as possible and organize your schedule and put yourself a milestone. When are you going to finish step 1? Are you going to finish step 1 today, tomorrow, during the weekend? I don't know. But step 1 is going to help you to know that you're moving forward. There are 3 steps. 1, what I described with the classes, the packages, and the connections, the output that I just explained to you. Step 1. 2. Easy. After step 1, what you have is in the console the numbers. There is nothing on the screen. The only reason for the screen to exist is for you to click. In the step 2, I want you to draw a circle in the position in which the user clicked. So hopefully we agree that there are two different things. As a user, I make a click here. The listener is going to have access to the coordinate, but nothing is going to be on the screen. If I want something to appear on the screen, like these circles, it is one functionality of my program to draw that circle. So my step 2 for you is you need to draw the circles in these particular coordinates. I am asking you to use those numbers to draw the circles. What do we need to do in order to do that? Where we do that? Where we can draw these circles? Okay, very good question. This one, the assignment is going to be individual, so not teams for these things. You're going to work alone. There is a small amount of work to do. I am giving you diagrams and source code, and I really need to be sure that you review this individually because it's going to be part of the things that you're going to do alone during your exam, your final exam. So individual work, the assignment. Yes. So to draw the circles, let me tell you this, two things. Number 1, can you agree with me that we need to store this information? We have those numbers, but can you agree that we need to save that data in some place? Variables, data structures, whatever, that information is going to be useful and need to be stored in some place. We need to talk about where, but we need to save those numbers. That is one thing. The second thing is we need to use that information in order to do the draw. So two different things. The information need to be stored. And then we need to use the information in order to do the draw activity. Okay, two things. In that moment, we can include the Blackboard pattern. Because hopefully you agree with me that if we are going to store information, well, the Blackboard is a pretty good idea, a pretty good place to store the information, right? In particular, hopefully you agree with me that the information is here. Inside of this method, in the class reporter, that is inside of the folder controller, the information is there. That is the first place in which the information arrives. What we need to do is to put this information that is there, as we reviewed previously, there. Now, the red line that I draw is kind of our goal. The information should move from that yellow box to the blue box. We need to review how. It's going to be like that, a direct connection. It's going to be a connection between other things that are going to be here in the middle. I do not know. We are going to review, but our goal is the information that is there should go to the Blackboard. Now, the draw, the painting. We want to draw circles on the screen. Tell me, in which class, in which method, we can draw blue-colored circles? There is only one method here that can do that. There is only one place here in which I can draw those circles. Where? Yes. That's right. Okay, so what you are asking us to do is we already have these yellow boxes I explained you before. And according with the next step, step 2, is to save the data and do the painting. Using the patterns, we know that saving the data is to put the data in the blackboard, and we know that do the draw is something that is going to happen here. But in order to that happen, we need the data, and the data is going to come from the blackboard. So step number 2 is we need to do the connections that I am showing on the screen. From this point to this point, but there are something in the middle that is going to help us with the data. Did you notice? From the idea to the design, and in every single step, there is a pattern that we can follow. Okay, how we do that? Next. What do you think about these new boxes? Number 1, we need a blackboard. We need a blackboard. The blackboard is going to be a class, the class that have the data structure. I am going to call that class. I am going to ask you to call the class repository. Blackboard is a repository. That class is going to have obviously a constructor and some methods and variables. I am going to talk more about the variables later, but did you notice something special in repository? Did you notice something special in my Blackboard here? And in particular, that special thing, well, 2 things special. 1, 2. I have a Blackboard, and connecting this with the design patterns, you notice that I am asking for one and only one Blackboard in the full classroom, one and only one Blackboard for my application. I am asking you to make the Blackboard a singleton. You notice that because 2 things. Number 1, I put the constructor private. Number 2, you can notice this reflexive blip. Only one Blackboard for the application. That makes sense. And also, I am deciding that my Blackboard is going to be observable. We did that before, remember? The full idea of the Blackboard, like the Blackboard in a classroom, is there are people working, inserting data, but that data is something that the others, the professor or the other students, or the students, if the professor is the source, everyone in the classroom is able to observe that data, to have access to the data. One of the common things that happen with a Blackboard is the Blackboard is observable. Another common thing, not mandatory, but common, the Blackboard is a singleton. 2 things. Okay, it's a class, observable, singleton, it's going to have data. For the first time, I am using YAMLs. In particular, I am going to put here asterisk. My Blackboard, my repository class, is going to store points and lines. I am going to talk more about it, but points. That is the first thing that I am asking you to store. Points, and how many? Several. This thing here. Can you agree with me that what I am asking you to do in that thing in the side of the circle is to create a data structure inside of repository to store objects from the data type point? If I put a number there, I will be asking for an array. If I put the asterisk, I am asking you for a dynamic data structure, maybe a link at this. Can you agree that that is what I am asking you directly with the diagram? That is the expectation of the source code. There is no other solution. It's a dynamic data structure because of the asterisk, and it's going to be a dynamic data structure to store points. If you're familiar with the class point, it's a class that already exists. It's a class that you can create if you want. It's a class to store the X and the Y. the X and the Y that we already have. I am asking you to store the X and the Y in an object. The name of the object is going to be a point, and you're going to have an array, a linked list, a dynamic array of all the points that the user created. So in my repository, in my Blackboard, we're going to store every single coordinate, X and Y, point in which the user make a click on the screen. Exactly. Yep, that is totally true. And that is the reason because I am asking you for the linked list. Usually, guys, if you have a class diagram and that class diagram have this asterisk, the diagram is asking you for a dynamic data structure. So starting with the linked list and all the others that you know. When you have a number there, one number, 2, 3, 4, 5, whatever, it's an array. And remember, it's a good practice as a programmer to use the simplest data structure. So if you have a number 5 there, you do not create a linked list with 5 elements. You create an array of 5, period. It's good use of resources. Anyway, storing the points there. Now, the important thing is, what are you going to do in order to put the information there? Because this, all this, is the repository, the data structure with inside of a class that is observable and is unique, singleton. Something that I need to do is to move the information from this method to this array. In source code, how can we do that? Well, is use a singleton, and you know how to access singletons with the name of the class. And in order to add data to the data structure, probably what I need is a setter method or an add method. I didn't put here any of those, but it's something that you know, it's something that you need. And I am sure that you're going to add that to the methods in the class. So at this point, hopefully, you are thinking about something here that is going to be like repository dot get instance dot whatever is going to be the name of your method, probably add, and use send the X and the Y. This is a line of code that you need inside of that method. That is what you're going to do. And that line, one line, is going to put the data there. Done. Easy. Professor, this guy is sending data here. Yeah. Next. This is observable. And this canvas needs to draw something. Can you agree with me that if this one is observable, in order to make this one, to have access to the information here, the easy thing that I can do is make this one an observer. And moreover, I do not need to show the connection in my class diagram. It is obvious that these two are connected, but it's a connection between two classes of the library. I do not need to show the line, but the line is there. Observer and observable, they are connected. There is a call of a method. One is observable, the other is an observer. My paint can have access to the information in the singleton. How? What is going to happen every single time that this method insert information here? Something that is going to happen is that the add method, this one, is going to call notify observers, yes or no? That is what should happen, right? And when this guy add, call notify observers, what is going to happen is that this update method here is going to be called. Did you notice? I add something here, call a method here, but this method here is going to call this method here. And this method, the update, the only thing that need to do is this. Repaint. What is going to happen when I do repaint in update? The observable call the update in the observer, and this guy, the repaint, is going to call the paint component method. One method calling the other. Software design. Our concern, the connections. And inside of each of the methods, there are particular activities, well-defined activities that are going to happen. Paint component. Do we understand what is happening in this source code here? All this block. Because that code is inside of the paint component method. Do we understand what is happening there? It's going to work? What is this? Establish that the color is going to be blue. What is this? Did you notice that repository get instant get points? Stack points. You are recommending us to create a method that is going to get me not only 1 point, but all the points in that structure. In particular, you are using a particular type of linked list, a stack. So I can get back all the points that are in the Blackboard. It's like look to the Blackboard and read not one number, but all the numbers there in just one step. And then the variable with all the information that I get, a loop, and get the value. Remember, we put the X and Y's inside of objects. So for each object, we open the object and we recover the two values, the X and Y. And using the X and the Y drawing novels, something that is important for you to remember. To draw the screen, you need to draw everything. The refresh of the screen, you need to redraw not only the new point, but you need to be drawing everything every time. So you need to recover all the dots and draw all the dots. It's not like use the last one, assuming that something that you already draw is going to be there forever. It's not going to happen. It's you redraw all the elements every time. Yeah, you need a data structure to store the information. In particular, for my example, what I use, what I stack. Remember, you have this linked list. You can use stacks, queues, or the original linked list. I am using a stack because the next step that I am going to explain. So far, according with my explanation, you need a data structure, a linear data structure to store the points. So far, you can use whatever, linked list, queue, or stack. There are going to be one reason because I am going to recommend you to use the stack, but I need to explain that in the next step. So a data structure to store the dots, and therefore the get points method return not one element in the data structure, but the full data structure. That means a pointer to the first element. That is really what is happening here, right? This get points is returning to me all the elements. Well, the address of the first one, and I can access all them. Good. So with this source code and with this idea that I drafted for you, hopefully we agree that what you have is this thing working. Click on the screen, you have the information stored. Moreover, you have the blue circles, and you can continue, and as many times as you click it, you're going to have this circle in the position in which you do the click. This one. Here, the method add that I described, or whatever name you want to use. Notice that I am not giving you a name for that method. I am giving you names for others. For this one, It could be add, set, up to you. So hopefully you notice that the fact that we create a singleton is useful and it's going to be used by the view in the class, in one of the classes. It's going to be used by the controller in one of the classes. In particular, the example that I described, well, you need to do this add observer. The add observer is going to happen in main. Remember, you create in main the canvas, so you need to create that connection of canvas as an observer of the repository. Hints for you. Good. Done. Working. Step 1, step 2, done. The reason because I explained to you step 1 and 2 with this level of detail is because basically step 1 and step 2 is the starting point. This is what you need to do in order to start working in the project. So far, I am asking you to start with this class diagram. If you remove my gray boxes and blue boxes, if you keep here only the yellow things, the classes, and the connection of the classes, this is the draft of what is going to be your class diagram, the beginning of your class diagram. This class diagram, this functionality. Okay, good. Next. And here, I stop drawing class diagrams. In this point, I stop giving you source code. In this point, your work. What I want you to do, the following. You are going to have an empty space. In your empty space, you click, and there is going to be a blue circle that appears. Okay, the first time, use a blue circle. Done. Second time, I click here, the blue circle. I already explained you how to do this. The extra. I want the circle, the new one, to connect with the previous ones. Which one? The closest one. I put this one. I click this one. Automatically, I am asking you to draw a line that connect these two. Click. The second time, click. You draw the two circles, but also I would like to have a line connecting the two dots. Okay, there is a method draw line. You need to use draw line in some place, and you already have the two coordinates, so it should not be so hard to draw the line. With two, easy. Next, the third time that I click here. I want you to connect this one with one and only one of the previous dots, the dots that already exist. Which one? The closest one. In this example, this dot should connect with this one, not with the other, because the other is far. Are you asking us that every single time that we click on the screen, we calculate the distance of that point with the others and select the one that is the closest one, and we connect with that one, align? Yes, that is my request. Makes sense, right? Question, what do you do to calculate the distance of the new dot with the others? Hopefully you agree that the only thing that you need to do is a loop. The loop is to calculate the distance with the new data that you have with all the coordinates that you have stored in the Blackboard. you need to store those distances in some place because you need the small value. There should be an algorithm for that, right? I mean, it's a problem that looks like someone else already solved or not. Here, two options. Option number one, you can apply brute force. If you are not familiar with computer science or any particular algorithm to solve this problem, you can figure out something using if, else, and loops. It's just comparing, calculating the distance, comparing the values. If you're familiar with computer science, you're familiar with this problem, I am sure that you can find an implementation, maybe even a library, to do this kind of work in a better way. Better, I am talking about performance, time. I do not care about the complexity or the timing. Any implementation that you create is fine. The only thing is solving the problem. Good approaches, there are a lot. You can research about it, or you can use a for loop and if conditions. Exactly, the shortest path. That is what I am asking you to do. And Dijkstra WordWare, yeah, that is okay. So again, several different options. This is not a computer science or an algorithm course, so I am not going to ask you for a particular implementation. The only thing is, this is the problem, several different ways to implement, up to your background and your level of experience. You can apply the solution that is better for you, easier for you. A dot here, and hopefully it's clear that if I click here, the next connection is going to be connecting this with this, just because it's closed. If I click here, and this one should be connected with this one. If I click here, this one should be connected with this one. If I make a click here, this one should be connected with this one, and so on. So click, 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 click. And what I am going to have is always my new dot connected with another one. Which one? The closest one. That is my request. Request number one, clear. Common question. Are you asking this to happen in real time, or are you asking the connection to be created after you finish to click the dots? I am asking this to be real time. Every single time that I click and a new dot appears on the screen, that dot should be immediately connected. For the user, it's like click, dot, connection, immediately. There is no run or calculate or something like that option. There is not like I draw the dots and then I ask for the connection. That is not what I am asking. It's real time, click, connection, click, connection. Good? Okay, that is number one. So something like this are you going to have on the screen? I use different colors. It's not a requirement, just to give you an idea of what is going to happen. Next, everything is great, but one small extra thing. When one point, any of the points, reach 5 connections, when you have a point and that point is connected with another 5, delete the point. What? Think about this one here. Right now is connected with 3. If I continue drawing dots around, like I put one here, and maybe I put another one really close here. Something like that. Well, this is not exactly. That when one dot reach 1, 2, 3, 4, 5 connections. What I am asking you to do, and again, real time, is that dot that just happen to have 5 connections, that one is going to be deleted. So this one, the green one, is going to go, but also all the lines disappear. And that is what I have. Next, because that one disappeared and I have the others alone, I need to recalculate. Do the same thing that you did before, but now instead of only with one dot, recalculate several dots. Recalculate, connect the dots. Probably, for instance, now the closest one to this one is that one, and probably this one is going to be connected with this one, and this one maybe with this one, and this one could be close with this one, and I don't know, it's probably close to this one. 5 connections, delete, and reconnect those dots that lost their lines. What I am asking you to do this, I am asking you to work with the data that is in the Blackboard, and I am asking you to put algorithms there. Where are you going to put those algorithms? Who is going to be the entity that is going to be doing these recalculations and all this stuff? It's going to be a new class? It's going to be a class that already exists? Solving the algorithm is easy. You can research the names on the chat. The solution is there. The solution already exists, and it's one method. The assignment is about in which class you're going to put that method. And that class is going to be inside of which package. And how that class is going to be connected with the others. It's all about the design. Yes, I am expecting this to work, but that is just 40% of your grade. The other 60 is your design. That is what we have been reviewing, right? Patterns and a good structure. So hopefully the requirement, the functionality is clear. Any question about the functionality so far? Points, 5, delete, recalculate. And hopefully now it's clear what I mean with this instruction. Now, next. All this work about delete and recalculate, what I am asking you to do is to think about that like the work for the professor, like the work for one of the entities connected with the Blackboard. Remember, I mentioned this like the control. In our example, we mentioned about the professor. Think about this. The dots are appearing on the whiteboard in the classroom. And I am asking you to think about the professor is the one that is going to be there and is going to be deleting a dot when the dot have 5 connections, and the professor is the one that is going to do this recalculation of reconnecting the dots. I am asking you to think about this responsibility, the things in the box, as the responsibility of your control, the professor. Do not mix control with controller. Controller is MVC, control is Blackboard. So just be sure to do not mix those two. Control, controller. Control, the professor. Controller, the listeners. So that's responsibility for the professor. For the student, the source of knowledge, the only responsibility of the student is to put the points, 1 point, and connect the point. So just imagine that you have the whiteboard and all the students in the classroom go to the whiteboard, put a dot, and connect the dot. So you are a student, you put your dot, connect your dot. And everyone can do the same. Put the dot, connect the dot. Put the dot, connect the dot. And you have the professor, and as professor, This one have 5 connections, delete, reconnect, delete, reconnect. Only the professor delete, the students use add. The students, 1 connection, the professor reconnect several. I am asking you to split the work in this particular way. You only recalculate for the dots that are now disconnected, only for them. So the others do not move anything. The dots that are free without connections, those are the ones that you recalculate or reconnect. Good. So this is a new class, and this is a new class. Yeah, please use control or professor if you prefer, knowledge source or student if you prefer. Again, the only reason because I am asking you for those names is to facilitate the grader. The grader is going to know what to check in those particular classes instead of kind of figuring out which class is what. So use for the grader. Yes, I am asking you to use the names that I am using in the slides, please. As I mentioned at the beginning, they are not the best names to use in a real environment. My only reason for asking for those names is the grader, facilitate the grading. Good. Okay, so far, so good. You're going to have this, delete, reconnect, kind of fine. The action, control or professor, student. One and only add. This one have the possibility of delete and can connect several at a time. This one, use 1 add, use 1 connection. 2 slides, and I am insisting on this because this is something that we're going to grade, that you separate these 2 responsibilities, mandatory. The students cannot delete, only add. The students cannot do more than 1 connection, only 1, and include the one that they add, only. The only entity that can do delete and can recalculate is the one that we call controller or professor. You can imagine the source code that you're going to have here and the source code that you're going to have here. And that is something that we're going to review. So just remember this idea, these cartoons, and create a source code that corresponds. Summarizing my closing statement, this is the class diagram that I am giving to you. This is the class diagram that corresponds to what I describe as step 1 and step 2. You need to start with the step 1 and 2. You can create the software that corresponds to step 1 and 2, the one that draw the dots. That is something that I could recommend you to do as soon as possible. So you have kind of your test bed to start developing things. After that, everything that I asked you to do in the step 3 is use these question marks. Question marks. What are you going to do to create a controller? To delete dots, to check if a dot have 5 connections. What are you going to do to draw the lines? And how are you going to connect these draw the lines that hopefully is going to happen here in the paint component with some information that should be here in the Blackboard? All the information should be in the Blackboard. That is your shared memory space. No information in the controller, no information in the knowledge source, something that we review. And I need to insist on this. Remember, when you use the Blackboard pattern, there is no communication, no connection between this guy and this guy. If you remember the diagram of the Blackboard, students talk with the Blackboard, professor talk with the Blackboard, never, never, never in this scenario, in this pattern, the professor talk or communicate in any way with the students, no, the students talk between them. That is the Blackboard pattern. That is the most common error that usually the students do here. No communication allowed between control and knowledge source or between one knowledge source as another. All the communication happen with the Blackboard in the middle. All the communication happen with this thing here. And that is a problem that you need to solve in your programming. How? Those parts, the red circle with the question marks, those are the things that I want you to add here. Adding implies source code, obviously, but also elements to the diagram. Those are the three things that we're going to grade in this assignment. What do you do to complete the architecture, the design, and therefore the implementation, the functionality of this scenario? So that's it, your assignment 5. Questions? Yeah, that is correct. You are not going to use the others method. So they are going to be empty. Remember, if you are doing the implementation of the interface, you need to put the methods, you need to override the methods. They can be empty. That is the only case in Java in which you have methods empty. The other option here in particular, if you do not like the idea of having empty methods, remember that you have this mouse adapter. The adapters are classes that implements the interfaces and basically have these empty methods. So the only one that you need to override is the method that you're going to use. So option number 1 implements the mouse listener and you have empty methods, okay? Option number 2, extend, because it's a class, the mouse adapter, and the only method that you need to override here in your class is that one, the one that you're going to use. You do not need to have empty source code. Up to you. Good. So any question, guys? Good. Okay. So I am going to stop here. Please, the slides are already on Canvas. I am going to post this video and the previous one. Any questions that you could have, remember, ask before the due date. Send an email to me, to the TAs. Any question, do not hesitate to ask. Do not wait to submit appeals after the due date. Any question, any doubt, anything that is not clear, watch the video again or send us an email, ask, but whatever. Should I use the same names? Can I create more packages? Can I create more classes? I do not understand if I need to use concurrency or not. Should I use threading or enable? I don't know. Any question? Do not hesitate to ask. Do not wait to submit appeals. As usual, very good question. Please, the only library that you should use is Java Swing. I am asking you to do the implementation with Java Swing as usual. So JavaFX, please do not use JavaFX. Use Swing. And in particular, I am asking you for this. That is what you should use. I am expecting you to use the classes that I put here: observer, observable, panel, frame, mouse listener. Every single element in the class diagram that I am showing you here is mandatory. All these yellow boxes, you should use them, and they should be in the package that they are in the slide. Other than this, step 3 solution, you should provide a solution, but remember, apply the patterns. What we're reviewing is that you understand the patterns and that you can apply the patterns. So mandatory, the yellow boxes, the red circles, give me the solution, follow the patterns. Yeah, your submission, very good question. I am going to give you this information on Canvas, but 3 things, as usual. Source code that should compile and run, your class diagram, a full class diagram. So it's going to be like these yellow boxes plus more, right? And number 3, a document explaining your design decisions. So as usual, a document, a diagram, and the source code that should compile and run. 3 things, and I can tell you the points 40, 40, 20, that probably is going to be the same distribution that in previous assignments. 40 for the code, 40 for the diagram, 20 for the document. Up to you. Multi-threading. I didn't mention multi-threading here. Runnable or thread are not part of my diagram, so I do not put them as part of the mandatory things. Up to you. There are 2 solutions, and it's depend of what you are going to do, but you can solve this with multi-threading, but also you can solve this without multi-threading. There is a tricky part. Up to you. I am open with both solutions. The only thing is the behavior, the functionality should be as the one that I described, and everything is real time. Good. So mandatory, the things that I show in the class diagram, those elements in the diagram and the source code that is equivalent to them, they are mandatory. Other than that, you are free, but follow the patterns. Okay, guys. Good. So see you next week. Any questions? Send us an email. Thank you.